This is 4.5. What is 6 divided by 3? 2. What is 6 divided by 2? 3. 6 divided by 1? 6. Now what about 6 divided by 1/2? How many 1/2s are there in 6? If I gave you a 6-inch string and I said cut it into lengths of 1/2, how many lengths would you have? 12. Okay, what about 6 divided by 1/10? 60. What about 6 divided by 1 over 1,000? 6,000. What about 6 divided by 0? Not. Your middle school math teachers were lazy and they said it's undefined because they didn't know how to define it. Well, I will define it. It will no longer be undefined. Well, look at the pattern here. When the pieces that we cut this string into get smaller, what happens to the number of pieces that we end up with? It gets bigger. So if we cut 6 inches into a lot of really, really small pieces, of pieces that are very, very small, how many pieces do we get? A lot. So all this is asking you to do is keep cutting the string until all of your pieces have no length. Right? So I give you a string, I give you a pair of scissors, I say keep cutting, and I want you to get every piece of length 0. And I leave. And I come back in an hour, and you have a bunch of little tiny pieces of string, and I say, nope, you're not done. Keep going. And I leave and come back, and you have basically string dust at that point, right? Not done, keep going. So it's what? It's infinity. Good job. So 6 divided by 0 is not really undefined. That's just the lazy middle school math teacher way of saying it. 6 divided by 0 is infinity. Now, are you ever going to get there? No. Is there any way to make those strings length 0? No. But the more you cut, the smaller the pieces get, and the more pieces you end up with. Right? So in theory, 6 divided by 0 is infinity. Whoa. All right, well, these two terms are related. 6 divided by 3 is 2, and 6 divided by 2 is 3. Okay, so what is 6 divided by infinity? 0. How does that make sense? Well, if I told you, here's a piece of string, cut it an infinite number of times, how big will each piece be? Very, very, very small. Now, can you really cut it an infinite number of times? No. But that's where we're headed. The more you cut, the smaller the pieces get. So what this is saying is, if you take a 6-inch string and you cut it until you're sick of it, then those pieces will be so small, we don't really care how big they are, right? Eventually, you're just going to end up with a pile of dust, and it will probably just blow away. And right? It'll disappear. So 6 divided by 0 is infinity, or anything divided by 0 is infinity. And anything divided by infinity is 0. Okay? Well, we do infinity math all the time in calculus. Just about every day. You can, once you get far enough into calculus, you do infinity math. And infinity math is really fun. What is infinity plus 3? If the biggest number you can think of plus 3 is equal to infinity. Infinity. All right, so what's infinity minus 7? The biggest number you can think of. Actually, infinity is not the biggest number you can think of. The definition of infinity is the number that is bigger than any number you can think of. You can't think of infinity. In fact, you can never get to infinity. So if we had an infinity counting contest, they said, all right, we're going to spend the next 24 hours counting to infinity. And whoever gets closest wins $1 million. Okay? So you got to count fast, right? So I say, on your mark, get set, go. And I say 1. And you count your heart out. After 24 hours, how far away am I from infinity if I only count it to 1? Way far. Infinitely far, right? If you counted to 10 million, how far away are you? Infinitely far, so we tied. Right? It doesn't matter how high you count. You are no closer to infinity than when you started. No, infinity plus 1 is exactly the same size as infinity. And infinity minus 7 is infinity. Right? How about infinity divided by 10? It's still infinity, right? Oh, that's the trick. Okay, Moosin figured it out. Infinity math is really easy until you do, I'm going to do something a little different, until you do this. Oh, well, infinity minus any number would be infinity. But any number minus itself is 0, and any number minus infinity would be negative infinity. And it turns out the answer could be any of the 3. Because even though infinity divided by 10 is infinity, there are some cases where one infinity is larger than another. Yeah, that's a little beyond the scope of this class. So in calculus, you look at this and you say, oh, that's a problem. And then you have to figure out which infinity is bigger. And then you do these little tricks to figure it out. Okay? So Moosin brought up a really good idea. What about this? Well, infinity cut into pieces is still infinity, right? But any number divided by itself is 1, and any number cut into an infinite number of pieces is 0. So infinity divided by infinity could be infinity, it could be 1, or it could be 0. It just depends on how big the infinities are. Yeah, because they're lazy. So we're not going to do that in this class, but I bring that up because dividing by 0 is a problem. When you divide by 0, the answer is so large, you can't write it down. Right? The calculator can't figure it out because the calculator only goes to 10 to the 99th, which is very, very, very far from infinity. So here we have a function, a rational equation, and we want to know, are there any numbers that you are not allowed to plug in? Well, there are 2 ways to break an equation. One is you square root a negative number, and the other is you divide by 0. Those are really the only 2. There is a third, but it's kind of in its own little category. But we dealt with this in the last lesson, and now we're going to talk about that. Are there any numbers that you plug in that make the bottom 0? -4. Okay, so here's what we do. We take the bottom, and we write equals 0, and then we just solve. So y equals -4. Y equals -4 makes the bottom 0, which makes the problem infinity. So if you look at the graph of this, at 4, it's going to look like this, and it could also be negative. If 0 is negative, then it would be negative infinity. Yeah, I know that's confusing. So if you look, there is no graph at 4. right? It gets close to infinity here and it gets close to negative infinity there. But if you try to plug that in, you get when y is 0, the function is either infinity or negative infinity. Yeah, it's an asymptote. Yeah. We'll talk more about those later. Okay. Well, what if the bottom was 9x, nope, 9 minus 3x. So we just write equals 0 on the bottom. Add the 3x. 9 equals 3x. So x equals negative 3. Now, usually this is what you say. Oh, it's not negative. I'm sorry. So here's how I like to write it. X is not allowed to be 3. Alex does it a little bit differently in this problem. It says, find the values that the expression is undefined. It wants to know which values don't work. 3 does not work. Oh, these are y's. I'm sorry. So you have to be a little bit careful. Sometimes it will say which numbers do not work, and sometimes it will say anyway, do you write not equals to or equal to? It just depends on how the problem is stated. Yes. Oh, you asked such a good question. Do we need to worry about the numerator? No. Is there any way to break the function by plugging numbers into x plus 2? No. The only time you run into problems is when you're dividing by 0. So if I factor this, what do I get? X minus 3 and x plus 3. So which numbers are not allowed? 3 and negative 3. Whoa. I said 3 and I wrote 9. Okay? Those two numbers break the function. And if you were to look at the graph, it would look something like this. It would look like something like that. There is no graph at 3, and there is no graph at negative 3. And we'll talk about how to graph those later. Okay. All right, what if the denominator was x squared minus 5x minus 6? How does that factor? They have to multiply to be negative 6 and add to be negative 5. So negative 6 and positive 1. So what numbers make the bottom 0? 6 and negative 1. Those two numbers cannot happen. If you plug them in, they don't go anywhere. All right. Yeah, that's not too hard. Okay. This is easy. Just plug in 2. Put 2 in the top, put 2 in the bottom, and simplify. Yeah, that was not bad. Okay. This one wants to know which numbers cannot happen. So you're going to factor the bottom, and you get plus or minus 2. Yep, same thing. Okay. Here you're going to plug in 6. That one's easy. All right. So here we have two functions. The first function's name is r, and it's written in the variable x. The second function's name is s, and it's also written in the variable x. So we want to build a new function. And the new function's name is r times s, and it's still written in the variable x. How do we build the function r times s? Well, we just take the r function, and we multiply it by the s function. Yep. So 2x squared plus 6x plus x plus 3. So 2x squared plus 7x plus 3. So this function's name is r times s, and it's written in x. That's easy. Now, what if I wanted to know r times s of 1? I just plug 1 in here. So that would be 2 plus 7 is 9 plus 3 is 12. Okay? But I could also plug 1 in there and in there, and then solve by. So let's see what happens. I plug 1 in there, and I get 3. And I plug 1 in there, and I get 4. What should I do with 3 and 4? Multiply them together, and I get 12. So that's kind of cool. You can either put the functions together, simplify, and then plug in 1, or you can plug 1 into both of the original functions and then multiply the answers together. Okay? Yes. So the r minus s function just says, take the r function, 2x plus 1, and subtract the s function, x plus 3, and we get 2x minus x is x, and 1 minus 3 is negative 2. This is the r minus s function. All right, the next one says, build the r plus s function and then plug in negative 2. But we actually don't have to build the function. I could just plug negative 2 in there and then plug negative 2 in there. So 2 times negative 2 is negative 4 plus 1 is negative 3. And then negative 2 plus 3 is 1. And then add those two together because that's what the instructions say. So negative 3 plus 1 is negative 2. Yeah. Okay, it will get harder, but not today. Okay. Once again, we have one where you need to tell me which numbers can you not plug in. So you're going to factor the bottom and set it equal to 0. All right. We have an f function. We have a g function. We want to know what is f divided by g of 2. So actually, all we have to do is plug 2 into the f and plug 2 into the g and then divide the answers. So if I stick 2 in there, I get 12 minus 5 equals 7. If I put 2 in there, I get negative 10 plus 8 is negative 2. So the answer is just 7 over negative 2. Okay. And now this asks, what numbers break f divided by g? So f divided by g would be 3x squared minus 5 over negative 5x plus 8. So I set the bottom equal to 0. Add 5x. 8 equals 5x. Divide by 5. X equals 8/5. That number will break f divided by g. So if it asks what makes the function undefined or what numbers are not part of the domain, all of those just mean which numbers make the bottom 0. So you just set the bottom equal to 0. Okay. Get to work.